Okay, welcome to chapter 7. We're going to kind of take a different turn from what we've been doing in chapter 6. We are going to start working with compasses. So 7.1 is what we're watching today. It is a little story about kind of how people used to build things. So think like ancient Egyptian times, like how on earth did they actually build these pyramids when they didn't have any of this stuff here. So they would use nothing really but a piece of rope. Ropes are awesome. Ropes can be used to create line segments, right? You can take, for example, like here's a necklace of mine. We'll say it's a piece of rope. You can make a line segment out of it. But, if you extend it this way and then go around, you can make a circle as well. So you can get two geometric figures out of just a piece of rope. It's basically how they came up with a lot of stuff, and it's how we're going to come up with constructions. So construction just means you're only going to use a piece of rope. Now, our piece of rope is going to look like this. You should have gotten one. If not, please make sure you grab one now. So this is not the classic compass that you would think of. The classic compass looks kind of like, the two ends together, and then you would put one end down and you'd circle around the other way. These are just what they call pointless compasses, not because they don't have a point, but because they don't have a pointy end, okay? So let's just practice once with these, kind of see how they work. Go ahead and put compass down on your page. You're gonna want a pencil. Pens work, but can mess up really easily, and then your constructions get really, really crazy. So I don't recommend a pen. I really don't recommend a marker. Just don't use a marker. You might see me use a pen just so that you guys can see it in the video, but I know exactly what I'm doing and what lines need to be drawn, so, I don't recommend these. I recommend a pencil. Wooden's fine. Mechanical's fine. Some things we need to identify. This right here, the little gold brass circle thing, is called a foci. It's the focus of the compass. I'm just going to call it the center. Okay, so this is the center of the compass, and usually that's where we're going to place our finger. One thing I find a lot of people do is they never mark the center, so please make sure you mark the center sometimes. So let's just go ahead. We're going to place our mark on our center. We'll see a mark on the page, and then we can go back, put it over that mark. When we want the compass to swing, we kind of hold that brass circle with our finger, and then we can pick any one of these dots. There's two options. You can pick one of the red dots on the outside, make nice big circles, just kind of swing it back side to side. Or if you put your hand on the other side, kind of like this, you can choose one of the inside dots and make smaller circles. So really any size circle from this, see sometimes it does get a little sticky, so you have to work with it, to all the way the heck out here can be made. So pretty hard to not be able to find the right size circle. These circles here are these dots here are offset from these dots here. And so if I needed a circle that was just tiny bit bigger than this circle, I'd go to the other side to find it. See how that works? Okay. So go ahead and just mark up this page a little bit, try it out. If you need a new compass, please let them know. These are 25 cents a pop, so they're not super bad if you break them. Yes, they do come apart. Please don't do that. That's how they break. But 25 cents times, all 1,000 freshmen, that's a pretty big chunk of money. So please don't break them intentionally. They are yours to keep for the chapter and then return at the end for a little bit of extra credit maybe, or maybe not. I don't know yet. Okay, cool. So go ahead and pause the video, try that out. Don't take too long. Take 30 seconds. Make a couple marks on this page, on this cute little story, and then we'll get back to the constructions. Alrighty, so I hope you had a chance to practice with your compass. Let's start constructing a rhombus. So over here on page 2. Knowing what you know about circles and line segments, how may you locate point C on the ray in the diagram above so that the distance from B to C is the same as distance from B to A? Describe how you would locate point C if you know, and how you know that BC is congruent to BA, and then construct point C in the diagram above. Well, since it's kind of hard for me to transfer back and forth, especially just we marked up that page, the best thing about constructions is that things like that, copying a segment exactly, we can do that. So let's go over here. I'm just going, well, first off, a straight line's a straight line. I don't care what you're talking about. Let's just go ahead and make our own. So we're not gonna copy that one. We'll just make our own. Kind of try to mimic the picture though. So here's my straight line. Luckily, it's a straight edge, so I know that's a straight line. I'm going to make it a ray, like they said. Here's the ray they're talking about. A ray has a point on one side and an arrow on the other. I'll go ahead and put, well, I don't need to do that. I'm just going to create another side here. Make it nice and long. One thing you're going to find is you're going to draw all over the instructions. You're going to have to extend lines, as you can see over here. That line's teeny tiny. We may not have, the ability. We may have to stretch it like that, and that's completely fine, okay? So you may have to extend lines. Every time you extend something, you will want to use your straight edge. Okay, this is our straight edge. These are unimportant. You will never need to measure something. Okay, in fact, we recommend against it. We're trying to prove you can do it without that. Remember, ancient Egyptians had no concept of one. Like, they had a concept of single item, but they didn't have one. They didn't have 1 inch. They had no idea what that was. So we're not going to use that. All right, locate point C. Well, here's point C. I found it. I chose it. Okay, so it's right there. There's point C for you. Super duper. Alrighty, let's go ahead and see how we can make that. Oh, no, I'm sorry. That's not C. Just kidding. That's going to be B. Oh, no, that was C. Sorry, here's C. We want to make point B the same distance this way as it would be to some point over here, A. Now, I could kind of eyeball it. Right, I could say, oh, it's like right about there. But then it wouldn't be accurate, right? We want to make sure that's exactly the same. So how would we do that? Well, if I put my center on B, suddenly that makes this a circle, right? If I draw a circle over here, then I will have the exact same length. Let's see if we can find C. Let's see, I found C. There you see, peeking through right there. So it looks like it's that dot. It looks like it's 1, 2, 3, 4, 5, 6, 7 dots for me. But it's going to be different dots for you, right? It's not going to be the exact same. So go ahead and find C so that it kind of peeks through. Make sure your center doesn't move. And then if I draw an arc, I'm going to see an intersection point over here, and I can label that A. Now, how do I know that A is actually the same distance from B as C? Well, what I've just done is taken BC and I've now changed it from just a line segment to a radius. This is now a radius. And on a circle, if I were to complete this circle, all radius are the same. You're going to find that's a very helpful tool, or a helpful little fact for this chapter. All radii are the same length. Therefore, and if you want, you can use the mathematical abbreviation, like kind of double arrow, therefore, or which implies. Therefore, BA, whoops, congruent to BC. Sweet. Okay, cool. We just found a radii. All right. Now that we have three of the 4 vertices of the rhombus, we need to locate point D for the 4th vertex. What the crap's a rhombus? Remember, a rhombus kind of looks like, I'll just hand draw it real fast. Kind of looks like this, in which all these guys are the same. So you could argue, no, that's a parallelogram. They don't have to be like I've drawn it here. It's just the classic one. You can think kite, diamond, squares, not rectangles, because rectangles don't necessarily need that, but squares are rhombi. Is that how you pronounce that? Rhombuses? I'm not sure. Anyway, the point is, the key feature here is that they are all the same length. So now we have 1, 2, 3 of the 4. We can kind of see our 4th one chilling over here, but we want to make sure it's the same length. So how are we going to make sure that's the same length? Well, what we can do is, first off, I'm going to draw the picture down here once again. So we're going to create a new array there, call it B. I'm going to pick C, then we're going to go up here. I'm going to make this one kind of fat, just a little practice there. And then I'm going to draw that same matching A, right? By the way, you'll see circles and arcs called the same thing. So if we only have a piece of a circle, recall that's an arc, right? So I've drawn the same arc. So this is the same picture here, right? I have A, B, and C. I want to eyeball this D over here. The question is, how do I make D actually the same length? I don't have one length that I'm copying, so what do I do, right? What I can do is I know that from here to here is that size. For me now it's the 1, 2, 3, 4, 5th dot. That 5th dot, I can just change where the center is and basically draw it again. Look, I was pretty close, right? But that's still, I don't know if I'm like, okay, so basically I've created another radii. We can see it goes back through B, which is super fun. Doesn't go through A, right? Because it's not the same center, but it does go through B because if this is the center and I made that part, then this is the center, I should make that part. But it doesn't tell me exactly where D is. Am I a little bit off this way? Am I a little bit off that way? Is it right here? Is it there? Is it there? Like, how far off am I? So I'm also going to take that same fifth dot, and I have actually forgotten which side it was. So I'm going to go back and measure again just because I forgot. You're going to find me do that a lot. Oh, it's this dot. And I'm also going to go to A. I'm going to draw another one. And look, it again goes through B, doesn't go through C. You're not guaranteeing that two radii will be the same distance from each other, but they should always be the same distance from the center. So that circle too does go through there. It also over here creates an intersection point for point D. And so I get point D out of this. Then if I just simply connect the last two lines from A to D, C to D, I get that same idea that because these two are both created, these circles are both created from the same radii, they are the same. All right. Now I am going a little fast. I'm doing this intentionally so that if you had any questions, we're going to get through all the notes, right? We only have so many minutes in the day. I'm going to get through the whole video. If you have questions, kind of write them down on the side, save them for the end. If you get lost, please, ask someone next to you, ask the sub. This video is also posted to Canvas should you need it. Okay, so we have now constructed a rhombus, pardon me. All right, now let's construct a square. As mentioned, squares are rhombuses, right? They are rhombuses. We all know what a square looks like. That have 4 equal sides, right? Squares are 4 equal sides. Well, squares are also rectangles. Rectangles have this 90-degree element as well. So squares are actually super picky, right? Squares, you can't just take a quadrilateral or a 4-sided figure and suddenly it's a square. It has to actually have like a lot of context to it. We figured out how to make the equal sides, right? We can do that. But now how are we going to make these 90-degree angles? All right. The only difference between constructing a rhombus and constructing a square is that a square contains 90-degree angles, like Ms. K just said. Therefore, we need to construct a perpendicular lines using only a compass and straight edge. Okay, that's a key point, right? We need perpendicular. I could, again, eyeball this bad boy and be like, yeah, here's a line. Yeah, here's about 90 degrees. But what if that's truly 89? Or 91? What if that's what I just drew, right? You can even kind of tell I'm a little bit off. So we need to make sure we are accurate. Otherwise, buildings we create, they're going to fall over. So let's construct a perpendicular line. Here we go. On RS below, or the next page, fold and crease the paper so that point R reflects onto point S. Based on the definition of reflection, what do you know about this crease line? Okay. Sorry, I have one-sided pages, so they will not peek through in the video. So here we go. Let's label this one R, this one S. This one's kind of tricky. We're going to fold it over. Okay, I don't know about you. I can't see crap. We'll fold it this way. I'm going to try. Let's see. Maybe this way? Okay, there we go. I think I got it. Oh, nope, I moved. This is incredibly difficult. This is not the way I would have done it. Go like that. Okay, so check that out. What do we know about crease lines? So now we've got this line here. It's folded in half. What do we know about reflections? That would tell us this is the bisector. All right, bisector. That is an incredibly inconvenient way to do that because I can't really fold buildings in half. Like, it's not really the best way, right? So how are we going to do this? How can we create a perpendicular bisector without having to fold the paper? We're basically back to that radii idea, okay? So it's kind of different. We're not going to copy any angles. I'm going to go to R, and I'm going to pick something that's kind of over this halfway mark. Now, if I hadn't folded the paper, I wouldn't be able to see it, but I can at least eyeball it, right? Like, if I choose something here, I know that that's over halfway. So I'm going to go ahead and pick some dot over here. I'm going to remember which dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's use 17. So whichever one you want to choose, you can do the same thing. I'm going to draw a really big arc. All right. Now, how does that help me? If I go now to the other side, I don't lose that 17th dot. You can see I just kind of held my pencil in there. If I forget, I also remember it's 17. But then I'm going to go like this. And now what I have is what I like to call the fish. I don't know if you see the fish. There's a fish, like a little Jesus fish. You could call it whiskers if you wanted to. You know, whatever you want to call it. But this is the perpendicular fish. And how does this help me? Now I know that this length and this length, so from here to here and here to here, are the same. Meaning, if I were to connect these two dots, these two intersection points, whoa, check that out. I got the exact same line. Now that, to be honest, is actually pretty impressive that I got the exact same line. Clearly, I've been doing this for quite a few years. Yours is probably just a little bit off based off how you folded it. But what I've created is a perpendicular bisector. So, the fish, any fish will help you cut things in half. It'll cut things in half perfectly. Sweet. Let's call this, I don't know, M for middle. More technical term for the middle of a line segment, midpoint, right? This will be M for our midpoint. Okay, now let's see, how can we create this into a square? So what can we do that will finally help us create a square out of this? And we actually just did number 4, so we're going to do number 5. This is how can you use the crease line to actually, you know, create a perpendicular bisector. But we're going to use this now to create a square. So here's our first half, right? Or we could go this way. It doesn't really matter. I'm going to head this way. Creating a square here might be a little hard because it's so big. So let's just draw another point here. We'll call it A. Okay. The letters are honestly not that important. Just make sure you label them in the right order. So here's A. I now have a segment. Let's create a rhombus out of that. Rhombus, we already created the angle we need. If I create a rhombus, it'll actually kind of throw it into a square. So how do we do a rhombus again? Oh yeah. First, I would put my point on M, and I would find A. Sorry, I had to move my laptop. All right, doesn't look like A's matching up on this side, so let's head over to the other side. Yep, there it is. Sweet. Okay, I'm going to put my finger there on the brass circle. Kind of circle it around, and there we'll call it, I don't know, B. Because why not? Okay, sounds good. Now I'm going to take that same one. I probably should have remembered which one it was. It was second dot? Yeah. So second dot there. I'm going to take that same one, and I'm going to use that second dot. Oops. Okay, hold on. I got to move the paper down. On both A and B. Okay. And then there's that intersection point. Really easy to lose which intersection point I'm talking about, right? If you have colored pencils, that may help. If you have something, this is too much a picture for you, right? Or you forget where you're going, colored pencils can help with that. Notice down here, I didn't bother finishing this arc out because I know I needed this point, right? You may also see a lot of the times people only draw these intersection points because that's what they know they're after, right? And we'll label this one C. All right, and then if we connect A to C, C to B, look at that. We have square A, C, B, M. I'm not saying A, B, C, M because that's not a square, right? It doesn't really matter what I label these as long as I label them in a square order. So I could also have named it M-A-C-B, B-M-A-C, B-C-A-M. You can go the other way. That doesn't really matter. But the person reading your name should be able to follow your shape around. And the person reading your name is me who's giving you the grade. So please make sure you label it the right way. And that is our square. We're not going to go back and erase any of our marks. Kind of the point was to see these marks and how we could create a perpendicular bisector, how we could create this. If you are super artistical, yes, that's a word, I made it up. You could, go over your final shape in pen if you wanted to. I might, in a couple of videos, do that so that you could see the final product we're after, but we see a square there. You don't have to do that. Please don't think you have to do that. But we get a rhombus. We know because that's how we constructed the other rhombuses. But as we saw, those rhombuses, definitely not squares, right? That's way too lopsided. Because of our added perpendicular bisector, we know that's one, that's a 90 degree, that's a 90 degree, that's a 90 degree. And thus we've created a square. All right, cool. That is 7.1. Today we kind of looked at a lot, but if you have any questions now, go over with the sub. Otherwise, you can go to your toolbox, write down a few notes from the key that I've provided, and then head to your homework. Thanks.